Okay, all right. So today we'll look at the last part of layer 2 security, and next onwards we'll move to layer 3 IP layer. And here, we will also revise a lot of concepts, okay, that you possibly know or you possibly do not know, right? So, and we'll also look at VLAN. We'll just look at VLAN. We'll not go into the attacks on VLAN, but VLAN itself provides security. Okay. So contents are from the same sources. Not many books cover enough details about VLAN security. So I've taken contents from some papers. So this is what we have done in last class. We have looked at DSCP attacks, and then we had looked at how ARP works. Okay. Today we will look at again. We look at ARP for very brief. Whatever we have learned, we will revise. Then look at two attacks. Basically ARP is spoofing attacks, which can have multiple sub attacks inside. When you say word spoofing, means that a machine can pose as somebody else. Okay. So all right, or spoofing somebody else's MAC address. Okay. Then we look at what VLAN is, and then I will leave it to you to study VLAN attacks. All right. So last class we studied about ARP. Okay, ARP address resolution protocol is required because as part of DSCP, node gets IP addresses of say default, say the router and so on, right? Okay, or within a subLAN, within a LAN, a node may have IP address of some other machine, right? But may not have MAC address. There's also possibility the MAC address is changed. I mean, IP address, for example, is known. Person would have come to know IP address through some mechanism. Okay, say domain name server or machine, your laptop would have cached in the IP address of some machine. It could be that that machine with whom your machine wants to communicate has a permanent IP address. Okay, so let's assume that IP address is known, then MAC address, and all the communication happens at the MAC address, right? So MAC layer or Ethernet, and that Ethernet frame is to be sent from one machine to another machine, and that frame will contain IP packet. Okay, so it means that even if we want to send IP packet to other machine, the Ethernet address of that machine is to be known. And then this protocol is very simple protocol. Like, I mean, in the classroom, for example, I mean, teacher may say that some roll number, say 1256, whose roll number is 1256. And then the person, everyone is listening. And the one who has 1256 will say that, yeah, I am Ramesh and my, this is my roll number. Well, similarly, it may happen here, right? It will send a broadcast to everyone. This is the IP address. And I want to know MAC address. That all machine listen and reject, will not do anything. Only the one that has this particular IP address will respond back. So this very simple protocol that we use very often in life, right? Okay. Now there is a possibility in the classroom that the person, whose roll number is announced or broadcasted, may be sleeping or may not be in the class, or maybe some smarter one may fake that. So my roll number is this much. Okay. So now what may happen is that the receiver will get wrong information. Now in the live class, there's a less possibility of that. Okay, but normal on a subnet, the machine which is the fastest one in responding may win. Okay, so there are a lot of loopholes here in this protocol, right? Okay, so because note networking world is designed based on trust, because ultimately this is a distributed computing, right? Same protocol runs in both ends. Similar state machine. State machine is same, but for sending and receiving, but states could be different. So it's based absolutely on trust, and that trust is broken by cyber criminals or attackers. All right. Now you can see that same kind of attack happen at all layers because of this implicit trust, that why should anybody fake my MAC address? But there is a machine who can do that. So say, for example, you walk into you are in CS department, you go to mechanical engineering department and you see some Ethernet port, you insert, you connect through cable your machine, your laptop to that port. What will happen? Would it allow you? What you'll do next? Think about it. Would that network or switch, the local data, reject your machine? How does it reject the machine? It has to first know. You may be a genuine mechanical engineering student also, right? I mean, there is a possibility. So it cannot reject. Okay, it will accept the packets from you. So that itself is a vulnerability, right? Is it? You think about it, right? Is it a vulnerability or not? It's a legal thing. I mean, you may say that, yeah, I mean, I'm doing it. I don't know. You can say anything, but should the switch allow you? No, switch should not allow you. But can you disrupt operation of that? Yes, you may. But how? Just think of a real scenario, right? I mean, possibly I've used this example earlier as well. Suppose you and your friend are bidding for something, and for that, for example, let's assume that a laptop is in the campus, laptop is for sale, and then the guy says that, okay, I can give the laptop for 5,000 rupees as a good laptop. Both you and your friend may want to bid, but the person says that I want money immediately. You may not have 5,000 rupees cash. Both of you may want to go to bank to get the money. Okay, whoever gets it first will win. Now you may want to win in the game, right? So what you will do is that you, or possibly it doesn't matter, right? I mean, your friend may take the money later, and yet somehow he can reach a destination first. So you may want to make sure that your friend never gets a chance to go to the counter. What you'll do? It's a fair game. Unfair means, of course. Okay, so what you will say that, okay, I have about 20 friends with me, and they will all go, and then make sure that your friend doesn't get a chance. Or maybe instead of 10 friends, you can say hundreds of friends. Okay, and then they queue in front of the bank, and then this guy may not get a chance. Okay, so you're denying the guy opportunity. Okay, so now all these things can happen, that your machine, if you program, see, again, your machine may not behave in the way which is wrong, but you can program, because ultimately you can design a hardware or you can write a software such that your machine will continuously send packets out and change the MAC address and continuously send the packet out. Then it can disrupt. So switch has to accept those frames that are coming from you. Okay, the moment it happens, then you can block the whole switch working. That's the reason, you know, physical security is also very necessary. That, you know, you're CS student, you're not supposed to get into the lab of mechanical engineering department. As simple as that. Okay. All right. So coming back. So there's hundreds of such attacks are possible. That's the reason security at all layers are required. Okay. Okay. Now, what kind of attacks are possible here? This is what we know. Okay. First is that you can fake. I mean, a machine. Okay, this is a machine. Alice wants to talk to Bob, and Alice has Bob's IP address. IP address of Bob is known to, but Alice doesn't. But Alice machine now needs to know the MAC address of Bob. Only then this IP packet can be encapsulated into Ethernet frame, and here Bob's MAC address will come, right? Okay. All right. So Bob, she will do ARP, and Bob's machine will respond. So this is 2D here, and before Bob responds, 2D will respond here, and 2D will say, we'll give this mapping that Bob's, you know, we'll give the mapping of Bob's IP address. Because Bob's IP address anyway is specified by, and some unknown, you know, MAC address, non-existent MAC address, say X. Okay. Now Alice will get this mapping, the IP address of Bob and X, and she will store this. And next time she has to send a packet to Bob, she will create the packet, put it inside a frame, and use X as an address. It will go nowhere. Okay, switch will simply reject this, right? Okay, so these problems happen because, you know, ARP is again based on trust. Requests are not tracked. ARP announcements are not authenticated. Nobody knows from where the response is coming, whether the response is coming from 2D or actually from Bob. Okay. So this is simplest attack that we have seen just now. 2D responds back instead of before Bob could respond back, and he sends some unknown, you know, some non-existent Ethernet address, and Alice receives it, and the next time packet is missed. That's a one kind of attack, right? Second attack is that similar attack. Alice wants to know, Alice wants to send, or wants to go to Google server, right? She wants to do google.com. And from DHCP, she got address of default router, which is a kind of gateway router, right? From connecting to outside world. She has IP address of R. Okay, she has IP address, or we say IP address of R. But she does not have MAC address of R. She doesn't have this. So she may want to get the MAC address of R. What will she do? Okay, she will do. Now note that this default router is also on the same LAN. So she will do ARP with IP address of R, and she wants to know MAC address. Yes. Okay. So of course R should reply it back, but protocol allows anybody can respond. So 2D will respond with IP address of R, but hardware address of 2D, he will give, now I'm using he will give his own address. Okay, now next time what Alice will do? Okay, so Alice will now send a message in the Ethernet frame with MAC address of 2D. and inside IP, IP packet for Bob. Sorry, router R. So now 2D will continue, will receive all the messages. And that's called redirection of traffic. Any question?
Why won't Bob itself reply to this call?
Respond, right?
Yeah.
Bob will also respond. But 2D wants to defeat the purpose. She is just waiting for this to happen and immediately respond back. She has to win. Yes, you are right. There is a possibility that Bob will win, but 2D can also win, right?
Okay, so this is just a possibility that there's a chance that it might happen.
Yeah, there's always a possibility. There's a possibility. 2D, let's assume that 2D has faster machine, faster laptop. Bob has old laptop. You can think of scenarios, right?
What will happen if say 2D sends first replies first, and then later when Alice gets another request from Bob also,
There's
will she
also
go with the later one?
possibility. Yeah, there is also a possibility. So if Bob responds back, okay, then Alice will reject this because she has already created the entry.
Okay.
So we have seen that multiple responses can come. She has to select one. Okay, so all depends on intelligent design. You can design a switch which will know that this MAC address belongs to 2D. If this MAC address does not belong to a default router, well, this switch can be intelligent, right? Because getting the information, default router comes in trusted zone, right? A trusted party. Okay, then this mapping is known to switch, and switch knows may know that default router's hardware address cannot change. So then as soon as 2D responds back, then switch will come to know this as a false. So that's the reason, if you go to, for example, if you use this method in your home router, home switch, it will work. You can fool, but enterprise switches, this is not possibility. Okay, enterprise switches are intelligent. Yeah, there is a probability that 2D may not win, but if 2D is really intelligent and uses a better machine, then she will win. Okay, all right. Okay, can we do it using this method, MITM attack, man in the middle attack? Okay, simple, right? So Bob, again, same. Alice wants to know Bob's MAC address. She has Bob's IP address, so she wants to know. So she does ARP. So now 2D sends ARP reply with Bob's IP address and her own MAC address, as we have seen earlier case, right? So now Alice sends message to Bob. Alice thinks that she's sending message to Bob with Bob's IP address, but 2D's MAC address. So Bob's IP packet is encapsulated in 2D's MAC address. So now what 2D will do? 2D will receive the frame, take out the packet, manipulate the packet, and now send this packet, okay, in a frame with Bob's actual MAC address and Bob's IP address. Okay, using Bob's IP address, right? So this is something, it will happen this way, that initially Alice is ARP, and instead of Bob responding, 2D will be faster in responding and will send IP, respond with IP address of Bob and hardware address as a MAC address of 2D. And now next will happen is that Alice will send a message to thinking that she is sending it to Bob. So she will use IP address of Bob, but hardware address or MAC address of 2D. That's what she received in ARP. Now she sends it, 2D gets it. Next step is that 2D creates a message. Okay, some message or modified that message or some other message. with IP address of Bob and hardware address of Bob. So now Bob will receive it, thinking is coming from Alice, right? I mean, this in this message, you can also put in the IP packet sender's address is Alice's IP address. Would Bob ever come to know that the message is coming from Alice, is coming from Rudy, not from Alice? No, because Bob's machine usually take out the pack. I mean, any machine will take out packet from MAC Ethernet frame and give it to higher layer. Okay, so Bob will never come to know that he is receiving packets from 2D. Okay, all right. Any question? Can you design a switch which will take care of all this? Yes, that's the reason enterprise switches are designed to catch all these kind of problems. Okay, so their countermeasures are many. For example, you can use some kind of tool which will keep monitoring the interaction that are happening, and then find out if when 2D poses as Bob or router, then this can be found out. There's a one simple way, but it is usually not used. It's not very effective. Okay, then if you are using permanent IP address, then this mapping is known to switch, and switch can always find it out. Okay, which is called and machines can also have this mappings. Like Alice laptop will have a IP address of router and MAC address of router, because this router's IP address, for example, is a permanent IP address, or given for when the lease for that IP address is, for example, in years, then it will work, right? Otherwise, solution is that have intelligent switches with all kinds of intelligence built into it. Okay, so that will know that 2D is trying to act smart and using responding back with say router's MAC address. Okay, or may not allow response back from any machine apart from the intended machine. So there can be all kinds of intelligence possible, right? And generally these intelligences are not public. This is how a particular switch company scores over other company. Okay, all right, because this is all proprietary. All these things, you can use AIT, you can use many other methods, right? Deep learning or whatever. Okay, or some kind of I don't know deep learning, but maybe some kind of learning can be there, right, to find out this kind of frauds. Okay, so now start thinking how to make ARP operation secure. Can you come out with idea? Now we said that it does not have authentication, so can you use authentication here? Can you use hash in some way? Some use of hash. Can you use encryption? What features you can make inside a switch to detect these frauds? Can you come out with some? You have studied AI also, right? Think of some self-learning schemes which can find out this kind of frauds. Okay, one company that I'm aware of, where a friend of mine works in Bangalore, works on deception technology. Okay, this is Israeli company. So deception is that, I mean, what happens in real life? A police guy will pose as a drunkard guy and go and sit in bar and find out the activities. Okay, he'll pose as a criminal or attacker or whoever, right? And then observe. So basically, other people, actual criminals get decepted because of this. Right? So the deception here. So we'll keep observing what's happening, keep looking at the behavior of others, and find out there is somebody who is not behaving properly. Will note that. okay, and inform higher up. Similar technologies exist in the real life, right? And within machines, right? Especially in data centers and large servers and so on. Like there can be an employee who can be very close to management. He'll say management, and it happens in all organizations. Will say that please keep an eye on somebody, or or this guy keeps eye on somebody and informs higher up. Okay, so yeah, so all these things do happen. So you can see analogy in from real life to actual designs. Okay, all right. So any question up to this point? Okay, all right. So now we'll study VLAN. Are you aware of what VLANs are? Anyone? You would have heard of this, virtual LAN. There's word virtual here, right? Like virtual machine, virtual link, virtual computing, virtual memory. Can anybody tell me what is VLAN? Because all of us are using VLANs, and when you connect to a laptop to a switch, you are on a VLAN. Anybody? Have you heard of this terminology?
Yes, sir. So,
Okay.
sir, VLAN is a concept where we use the same switch, but we can group like four people or five people virtually. Like
Wow.
in a
Yes.
switch, yeah.
Very good, very good. Excellent, excellent. So we'll come to that. Very good. We'll come to why we'll need it, right? This, of course, is I have taken it from the very good book. I mean, I suggest all of you are interested in networking to read this Kuros and Ross. I'm sure you would have used this in networking. It's a very good book. Once you read it from this, you can use other books like Tannenbaum, etc. Okay, so this is typical institution network that were designed some 30 years back, 30, 40 years back. Right? Now, this is a central switch which can have large port capacity, number of ports like, this one port, second port. We are talking physical ports. Okay, it could be maybe 500 or something, right? Or maybe 1000. Let's assume. Okay. Now, 1000 is generally good enough to cover your institute, right? The number of faculty members, students, support staff put together may not be more than 1000. Actually, it has to be very less than 1000. Okay. So we can design a network in this way that we have a central switch, and then there are various departments, like your department, CS department is here, then there is electrical engineering department and mechanical engineering department. And then there are smaller switches, right? All these are Ethernet switches. And there is a router here because you need routing to go to the outside world. But communication within this net can happen over Ethernet. Okay, what is the problem here? What is the problem? Real problems, right? Okay, what will happen? So in the beginning, let's assume there is a power failure, everything that was there is gone. Let's assume. Okay, all people are still connected here, right? So what will happen next? These switches have lost all the learning that they have done, right? For example, you are here. So let's assume that it could be anybody. Say Ram, for example, is here. Okay, and was talking to somebody, say Chris, in this machine, right? Okay, that MAC address of Chris is known to you. Okay, so now what will happen now? So this switch knows that if a frame that comes from Ram For Chris, will go to this port. Okay, that learning is done, that Chris is connected to this port, and this port, I'm sorry, Chris is not here. So we'll go to this port, and this switch knows that Chris is connected to this one. It will send it to this one, and then finally Chris is here. So it will go to this port. This learning is there in the each switch. And this learning happens because of what? When the communication happens, switch learn. Otherwise, if in the beginning, when all are booting up and there's no learning, there will be broadcast. So this, Chris frame will be sent to everywhere, right? And this guy will send it to everywhere. And this guy will also send to everywhere. If there are 1,000 nodes, there will be 1,000, more than, close to 1,000 broadcasts. Okay. So bigger the network, broadcast will be, will cause lot of problem. Okay, so now we need to restrict the domain of the broadcast. Like for example, even if ARP is to be done, and these are all connected together, it means that effectively this is part of the same LAN, all machine of all departments. So when your machine wants to know, the Ram's machine wants to know Chris's machine, then it will do ARP. Okay, IP address known. So now there is and it means that all these machine will unnecessarily receive. So this is not good. Okay, so a lot of traffic will be there, and then we need to then isolate the traffic. Why should the traffic from CS department go to mechanical engineering department unnecessarily? And anybody may snoop, can find out what's happening in your department. Okay, and then of course, a lot of LAN performance impacted. Ultimately, bandwidth or traffic carrying capacity of not only links but also switch is limited. Link has limited capacity, so switch has limited capacity, and a lot of unnecessarily overhead traffic, which is broadcast traffic, is there in the process of learning and other protocols. Then the bandwidth is wasted, right? So efficiency will be less, and security. Anybody can actually get into anybody else's machine. Anybody can see what exactly is happening in other department's machine, right? Because it is often broadcast. Okay, so it's not a good idea to have hundreds of laptops connected or machines connected on a same switch, and they are all using same broadcast domain. Okay, so what we can do is a better network is this one. We can isolate this. This is my broadcast domain. This is other guy's broadcast domain. This is mechanical engineering's broadcast domain. Okay, which we call it IP subnet. Okay, and now all of these are connected with routers. Okay, layer 2 communication is only restricted to this one. Now you want to communicate with somebody in mechanical engineering department, go through router. You need to know IP address of that, and then it will go to a router here, and then the router will send it to right subnet. Okay, any question here? But what is the inefficiency? Is there some problem still? This works beautifully, and it is actually the way it happens in many departments, right? Now let's assume that all departments, now we are thinking of department, right? Within a department or within an organization which are on the same floor, there can be finance department, there can be technical department, there can be design department, there can be IT department. And we need to isolate the traffic of these two, right? Although they may in the same location. Now you may think that comp science department, mechanical engineering department are 2 kilometers apart. Fine. Then you can use this possible method. But if the departments can be in the same floor. Okay. So what we need to, so the problem here is that let's assume this switch has say 500 capacity. Okay, CS department switch has capacity of 500, only there are 100 users. Okay, if you're physically isolating switches, then you cannot use this remaining ports. You are inefficiently using switches, right? Okay. What will happen if you have more than 500? Suppose capacity goes to 500 plus. What do you do then? Then we buy a bigger switch which has much higher capacity. So switches don't come in incremental capacity, right? 512 could be a capacity, and 500, it doesn't come in 513, 14. Then next capacity would be 1024. Okay, and you'll have to make all these changes then, which is not good, because you remember that it's not only the cost of hardware, it's also the cost of the people, right? Actually, in IT departments or in organizations, the cost of people is usually more than the cost of equipment. Okay, so who will remove the wire, who will create all the new connections? All these are not necessary. Okay, so basically we can say inefficient use of switches when is underutilized, or when capacity goes up, then you'll have to do a lot of work. And the managing users, right? Okay, so for example, here, okay, you are in CS department. This is the building where you are working, and there is a mechanical engineering students, and there's a port available. Mechanical engineering comes here and connects the laptop, but wants to be part of mechanical engineering. And why should your environment of CS department get polluted with broadcast from somebody else? Okay, so you may want that capacity is available. You may want him to work in your department because he has been assigned a desk in your department. If, for example, in the same building, mechanical engineering department faculty can also get a seat. So, but he or she will be part of this subLAN, right? Mechanical engineering subLAN, right? Subnet. Okay, so can we do this by this method? Of course, it's not easy. It's not possible, right? Okay, so this is another thing. The managing user is problem because people can moving from one location to another location, while we have created this design based on the location, physical location, right? So this can pose another problem. Okay, so what we can do? Okay, so now what we can do is that we can have same switch, but we can configure this in such a way that it will be logically to different network. Okay, so VLAN allows us to split switches into separate switches. So we can say this is a orange switch and this is a green switch. This is CS department. This could be mechanical department, but it is placed in the same building, same floor, same lab could be, right? Now the traffic, that is broadcast traffic or traffic going from one machine here, will not go to this place. It will not happen. It will restrict only to these ones. Okay, and if you have to send something to mechanical engineering department settings, then you have to send it to a router which will connect these two. Although these two ports is a big switch with the ports, right? Physical ports, but still between green and orange there will be a router. Okay, all right. So we can say that this is a logical definition of VLAN. Switch supporting VLAN capacity can be configured to define multiple virtual LANs over a single physical LAN infrastructure. So this is a single physical switch or LAN infrastructure over which we can create multiple number of VLANs. Right now we have said, shown here only 2 VLANs. It could be number of VLANs, right? Maybe 5, maybe 6, maybe 100. Okay, and now we can define this separation based on the ports. These are the ports here, right? I mean, in a switch there are ports. Okay, so you can say port number 1, 2, 3, 4 belong to CS department. Port number 5, 6, 7 belong to mechanical. You can do it this way. Okay, this is one simplest way of creating VLANs. The other way is based on MAC addresses. You can say the MAC addresses a set of MAC addresses belong to CS department, other set belongs to mechanical department. There are a number of ways to define how VLANs, but port-based VLAN, we'll consider only port-based VLAN because it's simple. Okay, all right. And whole idea is to give you concepts rather than getting into details, right? So we can have, you know, we can, for example, this is first floor, this second floor, and this is the third floor. And now there are people of different groups are sitting here, right? Says the group A, group B, group C. Say, for example, this could be your treasury department or finance department. This could be your IT department. This can be student. There can also be faculty. They're sitting in the same floor. So now using this, you can create the concept of VLAN. You can have a switch here. Okay, common switch, and but you can create corresponding VLANs. Okay. All right. So this same thing that we have discussed earlier. Okay. However, traffic from one VLAN to another VLAN will pass via a router. So any machine is communicating to any other machine here will go via this router. Okay. All right. So it means that this VLAN switches have got to be intelligent enough. There must be some table, there must be some database which will know all these ports belong to E department, for example, and all these ports belong to CS department. Port number 9 to 15 and belong to CS, 1 to 8 belong to E department. This should be known. And then based on where the packet is, a frame is coming, it will take decision whether, suppose you create a frame, okay, and may want to send it to mechanical engineering, CS to E department, then the switch will know that it is it cannot go this way, right? That there's no direct path. It has got to go through router. Any question? And then there is a lot of intelligence, like I mean, a membership cannot be permanent here. For example, you may move, you are connected to this port here. Tomorrow you come to the lab, you may connect to some other port. Okay, now it is based on the port mapping. Anybody who's coming and connecting a laptop to a port, that particular port which is designed for CS department will become member of CS department, because here the CS department definition comes because of the what port you are connected to. Okay, all right. Any question? Okay. Now can we do it this way? Let's assume that you have a switch here and all ports are consumed. Okay, and you want to increase the capacity, you buy another switch. Okay, and that switch will also have, you know, E department machines and CS department machines. Like orange here is E department, red here is E department, and light blue is CS department. Because, you know, E department also wants more ports and CS department also wants more ports. What do? You cannot throw this and buy a bigger switch. You buy another switch and do it this way. Can you do this? Yes, we can do this. This is called VLAN trunking. Now you here in this concept, you have a port which you call a trunk port, and similarly a port here is trunk port which carries traffic for everyone. That is for CS department, E department. Okay, it means that whatever traffic is coming is happening will go on the trunk port to other side. What do you need for this? What kind of, so now frames of both kind will mixed up. And then switch here when it's, how will it know that it's mean for EE department, not for CS department? Okay, it means now some kind of info has to be there, which we call it VLAN ID. Because you give a VLAN ID to E department, which we have shown actually implicitly, explicitly with red color, right? And then VLAN ID for CS department is a blue. Okay, now normally Ethernet frames don't have any field to represent colors, okay, or IDs, right? But there is the protocol that is defined, which is called 802.802.1q is by IEEE, says that we can define these colors or tags. We call it tag. Now tag is VLAN ID number. The kind of is one parameter is VLAN ID. Okay, so now let's move to that. So now we have this kind of frame. Okay, so now what, the moment here in this trunk, which connects these two ports, trunk ports, whenever a frame is received for VLAN, say X belonging to E department, it will be given a VLAN ID. Okay, it will be, so similarly green one will be given VLAN ID, and then when it receives the other end, it will be sent to respective LANs. Okay, so that's what we call as, we have concept of tag. Okay, and when, so tagged frame will go through this trunk which connects two switches. Very simple. Now you can see that there is a VLAN ID number. Who gives this tag? Who will, in the beginning, you know, Ethernet receives, let's assume that it is ordinary frames, right? Ethernet frame. The responsibility of tagging, now you have to think of what can be designed. Tagging is here, the switch will tag. It will create a extra field and tag it. VLAN ID will come here, and then it will go to other end. And this guy, before sending it to machines, laptops, will remove this VLAN tag. Okay, so this is the concept given here. All right, so advantage of VLANs, improved security. Okay, because broadcast domain is restricted within that group, right? Okay, you will not, a CS student, you will not get to know information about mechanical engineering department. Reduce cost, instead of buying multiple switches and every time increasing the switch size and so on, you can have one large switch, and you can also increase the capacity, you know, by adding new switches of different capacities, right? You can connect a VLAN initial switch, for example, of 1024 with, if the capacity goes up, you can buy a switch of say 256 port and connect to that. Okay, better performance, of course, you don't have broadcast domain, which is big. Okay, IT efficiency, you know, IT efficiency means that it is easy to manage. There's a one switch, you know, it's easy to manage than 100 of switches, right? Okay, and there are a lot of VLAN based attacks possible. I like VLAN hopping attack. You know, when, see, there is a process, how do you create this, you know, trunk port, etc., right? So there are a lot of protocols around that. Okay, and something called double tagging attack, VLAN hopping and double tagging attack. So you know, okay, a switch can be, according to Cisco, a switch can be a port can be made a switch port, or what do you call that, trunk port. So attacker can connect to any port and use a protocol called DTP protocol to make this a trunk port. The moment it becomes trunk port, now all these protocols have been designed for management, right? But can be exploited. The moment it becomes trunk port, then everything, all the traffic from all VLANs will pass through this, and this guy can listen to that. Okay. So there are some methods given here. So and similarly, multiple tags one can use to get into different VLANs, right? So we'll not get into all this. If you are interested, read it. Okay, and similarly, we can have spanning tree protocol. How can you disturb the spanning tree? Because you know that you know switches can be connected only in a spanning tree way. Otherwise, broadcast will continue to happen. One packet will circulate for millions of times. In order to avoid that, switches are interconnected in such a way that loops are avoided, and we have spanning tree protocol. And how can you disturb the spanning tree protocol? For that, you need to understand how spanning tree protocol works, because it's standard protocol, and you create some frames or packet and disturb that spanning tree, right? So SCP attacks are there. So we'll not go into that. So with this, we will complete our discussion on layer 2 attacks. We have seen CAM overflow attack, DSCP attack, ARP poisoning attacks. MAC address spoofing attacks also, we looked at it. And then VLAN, we have seen VLAN by itself provides security. Okay, but a lot of attacks are still possible, right? And for all that reason, switches are made intelligent. So the low cost switch that you buy for your home may not have all these features. All right. Okay. All right. Thank you. Any question? All right. Thank you. So we'll have class tomorrow at same time, 9 o'clock. And those of you who have time, please attend it. Otherwise, go through PPT. So tomorrow we'll discuss IP. The first part will be how IP works, right? Whole idea is that we must visualize, and then we'll come to know. Attacks are possible if, once you understand the concept, then you can understand how attacks are possible on those protocols. Okay. All right. Thank you.